Welcome to the fourth tutorial of IAT 355. Today we will be talking about how to work with GeoData. There are a couple of things that we need to understand first. One of them is datum, the other is projection. Datum is a coordinate system that is used for locating places on the Earth. Just like the coordinate system X and Y, this one is used to locate place on a spherical shape, which is the Earth in this case. So, a geodetic datum has many standards. You will be able to find them in this website, special referencing or specialreference.org. So we will be using the World Geodetic System, which is supported by D3, and its technical name is this number. It's a standard longitude and latitude reference that we will be using in D3. So why is it important to talk about different standards? That's because depending on your project, your assignment, or your objective, you need to understand what type of coordinate system the data that you have access to is using. For example, this is a GeoData that the government of Canada is providing. To work with this dataset, let's take a look at the metadata. Let's search for EPSG, and as you can see that they are using two different formats or coordinate systems, 4617 and 5713. So you need to find this coordinate system for any dataset, and if that is not supported by D3, you need to convert them to something that you can work with. There are many softwares available to make this conversion, but it's hard to get access to them because not all of them are free. I encourage you to talk to Research Commons to know what SFU has access to and what not. However, if you have a small data set, you can use this website to convert from one coordinate system to the other. Alright, so let's now talk about projection. Basically, how you can flatten the sphere into a 2D screen or into an XY coordinate system. D3 and VegaLite both provides different types of this projection. You can find some of the D3 ones here, and D3 or VegaLite actually. Let's also take a look at the documentation of projection in VegaLite. VegaLite can project two types of data. One, individual points that has a longitude and a latitude. Also, entire geographic regions, which are not just single points, that are entire regions. And instead of using longitude and latitude, we will be using GeoJSON to represent entire geographic regions like countries, states, provinces, and etc. In VegaLite, we have to mention which type of projection we will be using and its corresponding longitude and latitude. There are different types of projection types. One we will be using is Mercator, but depending on the dataset you have and your objective, you might have to use a different projection type. Okay, so now that we know a little bit about GeoData, let's talk about data formats. The file format that is natively supported by D3 is GeoJSON. As you can see that the geometric data, the longitude and latitude, is stored under the coordinates value, and if there are additional properties, they will go under this segment. In that case, the type will be feature, which is usually the case. One of the datasets that we will be using today is of type GeoJSON. This would be the Vancouver Crimes, which is of type feature collection, and if you look into the features, every feature has an object of type feature with a geometry which has the longitude and latitude and some additional properties describing what type of crime it is, picture, and other sorts of data. Other than GeoJSON, we have another type of dataset, Vancouver areas, which is of type TopoJSON. TopoJSON is another type of file format which kind of stores the same data but stores it in a different way. It is an extension of GeoJSON where the geometries are not stored discretely. Instead, they're stitched together, which are called arcs. This means that the data points are no longer stored as individual latitude and longitude. Instead, they are converted into arcs. In this way, data is stored more efficiently in the sense that the data size are much smaller. However, it takes more processing power when you're loading this dataset into your notebook. This would be our Vancouver areas dataset, which is sort of a little bit more complicated compared to GeoJSON. Simply, it has just a lot of hierarchies. If you keep going down, you'll find a feature object just like before, which also has a property, a geometry which is of type polygon, and eventually it boils down to the longitude and latitude. To play around with the data you have, you can also look into this link where you can load in your GeoJSON .json files. This will allow you to inspect the data you have. However, this does not allow you to convert from one file format to the other. Alright, enough about theory. Let's talk about codes now.